Good afternoon, everyone, and welcome to the Real-Time Analytics Track 1, a dedicated breakout session for Flink Forward Asia 2025. And my name is Jack Wu from Alibaba Cloud, and it is absolute honor to be the hoster of this track, and we have a lot of experts here to show the real-time analytics with Apache Flink. So today, now is the time to deep dive into the first session. We are thrilled to welcome Kevin Chen and Yuanzhe Liu, senior software engineers at Grab, for our open keynote. They will present from data streams to actionable insights, Grab's journey with Flink in real-time analytics and data quality. Welcome them.
Thank you. Hey, hello everyone. Thank you for attending our session for today. So I'll just go through very quickly about our agenda. So firstly, who are we? A sneak peek about what is Flink at Grab. We bring in today for two use cases. One is about real-time analytics and one is about the data quality. And final one is the Q&A. So who are we? So I'm Calvin, and together with my colleague Yuanzhe, we are the software engineer at Grab, and we're doing the stream application and infrastructure at Grab. So speaking about Grab, everyone will know that Grab, we are one of the Southeast Asia leading super app where we generate a lot of data every day, every minute. So that's why our system on Flink is also quite a big. We have around 600 plus Flink pipeline and 200 Kafka topic to serve a few hundred internal service. So with this kind of data, we also got facing a lot of pressure on our platform, on our behalf platform, how our platform look like, how can we maintain the platform, and also how we make sure that our platform can easy and best to use for our internal users. So that's why the second section will be about the Flink at Grab, where we just introduce a bit about our Flink SQL platform. So the motivation behind the platform is whereby at first we thought who is our user, who can use our platform. So the user inside here is data scientist, data analyst, business user, or basically the low-code user, where we don't feel right that we're asking them to write a Scala or Java code, or maybe they even don't know what Java look like. But with that one in mind, we come to the conclusion that everyone inside, all of the user will have a common language, which is the SQL. So for the SQL, we just need to pick the right platform, which is the Flink SQL, and provide a self-serve platform, self-serve service that with a correct UX UI design that everyone, the local user, can be used. And how the platform look like is this one. So for this platform, what happened is the user can simply just put inside the SQL, do a try fail, and select, write their logic, write their business until they feel happy with the business logic and to able to solve their problem. Then they can click on the deploy platform, which is the right button, the button over there. So when they click to the button, they can create a Flink pipeline with all of the configuration, like what is the connector, what is the sync, where should it go to, where the source, and that's it. The platform will be running, and we will do the rest for them. It's just like set and forget, where they just set the pipeline running and forget it's already there, and we will do the work for them. So that's how the platform. And this platform is also behind the scene of these two use case that we are presenting next. So for the first use case we bring here today is merchant reporting. It's a business use case that help the merchant to tracking the advertisement campaigns. So to set the context first, so the merchant reporting mean inside here is that the merchant is one of the Grab business partner. They can be the food store, they can be the restaurant owner, or can anyone else that using Grab to sell their service. So on the when they do on the platform, we provide for them something called the campaign management, where we have them to marketing their restaurant, their store on the mobile app to get more customer. And for that, when we come to the report, there are three kind of report that do particularly for the marketing campaigns. The first report is the merchant report, which is the user can see, the merchant, the user can see on the app, where they can see what is the sales, how is the performance, and different kind of metrics relating to the advertisement campaigns. But the matrix, so currently the matrix is generated from the ETL, so that will delay usually around like 4 hours. The second report is a list of all of the campaigns for the merchants. So the second report is mainly for the campaign manager to see and to check all of the list of the campaigns. So those metrics like advertisement spending, impression, clicks, or click-through rate, everything will be inside here for the campaign manager to check. And the third report is a single campaign report, where when the advertiser can click to see how one of the campaign look like, how the performance, so they can make the right decision for the advertisements. And yes, all of these things come to the challenge that it's about delay matrix. Why delay matrix is because it's the ETL, everything on the leg. So that's why the matrix usually delay around like 3 to 4 hours. And with this delay, it's very hard for the merchant to able to see instantly how is the performance look like. Like for example, if they are a food stall and then 4 hours later, they look at the app and say, oh, why don't I have any sale even I'm in for the campaigns, which it doesn't feel right. And even for the advertiser, which they see that like, how can they make the correct decision to adjust the campaign, which help the merchant to get more customer. So that's the first thing. The second thing is related to the incident handling. So in incident handling inside here mean that, so for example, some of the metrics on the report, they feel doesn't right. It's not very right to them. And they need to change the calculation of the matrix. But as I said, because we are one of the super app, so that's why a lot of data keep coming in. And we need to do the backfill. But when the backfill happen, it will take around even like daily or 1-2 days or even go to a week to be backfill. And with the backfill around a week, then it become like very frustrating for the merchant as well. So that's why the solution is we bring everything into the real time, where we have the fast reporting layer, and everything is going to Flink for instant reporting campaigns. All of the campaign reporting instantly from the 3 to 4 hours into a few seconds or milliseconds. And the secondly is for correcting the daily activity, we also have another data reconciliation layer, where we will use a golden table to ensure accuracies. But for today's topic, mostly about Flink, so we won't talk about the data reconciliation, maybe in another conference, but not today. So I will be focused more on the Flink part. So maybe some of you just say that, oh, it's just a reporting, it's just a matrix, where it's just a few aggregation, then that's it. Nothing fancy, nothing important. Yes, it's nothing fancy, but it's not very, I cannot say that it's not complex. It can be easy as we have one topic, simple aggregation to have a report, like report 8. It's also very complex. If we have, for example, using 2 topics, do a filter aggregation and making a report B. Or even we using the filter topic together with another topic, like topic A, to create a report C. So we see right, all of this one, it look okay, it look not very complex, it looks simple, but all of the logic, it comes from the user. And it's the logic come from the user. We are like, if the user doesn't know anything about SQL, doesn't know Flink, or doesn't know how to write Scala, Java, C++, etc., they cannot do it. And we also cannot help them to do that. It's very frustrated. Like a lot of requests come in, and we cannot like keep writing the report to them. So that's why we back to the question that's why we write the platform earlier. So that's the platform can self-serve them. They can just go inside, create the logic, and everything set and forget and put it there for the report. And if you guys interested in the platform, we also have a blog on our Rap Engineering blog about the platform more detail. You can take a look. And for the second case study about the data quality, my colleague Yuanzhe will be doing that one.
All right. Okay, thanks, Calvin. So just now, my colleague Calvin shared how we use a Flink SQL to help our merchant to generate a real-time report. Then there might be such a question like, firstly, is this kind of a report accurate? And secondly, if there's any issue with our data, how do we identify those data quality issue in a very short time? So here, I would like to talk about another use case in Grab, which is the real-time data quality monitoring. Okay, firstly, let's think about the challenges that we might face to identify the streaming data quality issues. So there are three major parts I would like to talk about for this kind of challenges. Firstly is the semantic issues. Semantic issues is something like, how do we know the data is correct? What kind of data is correct? Well, the second part will be the timeliness. How fast can we identify there is a data quality issue? Well, the last part will be the poison data observability. Once we identify there is a data quality issue, how fast can we figure out what's the root cause of the data quality issue? Yeah, let's go into the details. Okay, firstly, the semantic challenges. Yeah. Let's take an example of the protocol schema. So you guys might know the schema actually is the place where we define our data structure. For example, we have a marketplace entity here, and it has a one field called ticket ID. And both producers and consumers will use this kind of product schema as an agreement among them, so that they can use this schema for the serialization and deserialization on their client side. Okay, so let's say we define the schema of, we define the TK ID field in the schema, and the field type is string. But how about the field value? Let's say we could have such requirement like the field ID should follow some pattern, like ABC colon plus numbers. And let's think about this kind of a scenario. Producer 1 is using the correct schema and try to produce the data into the Kafka topic, and which is following the semantic rules, which is ABC colon 1, 2, 3. Well, the other producers using the same correct schema, but instead it is trying to produce some data that violates the rules of the pattern that we defined, which is ABC column numbers. So both of them using the correct schema. So during the execution, there won't be any issue, but the result is there are some correct data that fulfills the requirement, and also some wrong data that violates the rules exists on the same topic, which might affect the downstream users, which is our consumer 1 and consumer 2. Okay, here we might think about one thing. Is it possible for us to make a similar thing as schema for semantic, so that we can use this kind of semantic rules as a contract between among producers and consumers, so that we will know whether our data is correct or not? Okay, next challenges, timeliness. Okay, let's think about this kind of scenario. In the first time around, one producer tried to produce some poison data into our Kafka topic. Then after some time, our consumer identified there is some data when there is some data processing happening in the consumer, and they identify this poison data, then they report this kind of data to the producer side. Then after the producer side receive this kind of complaints, then they try to fix this kind of data issue. Let's think about the entire flow. It might take a few hours or even days from the poison data producing to the Kafka topic until the producer side fix their logic to generate the correct data. And the second issue could be all the data validation is fully relying on the complaints or reporting from consumer side. What if no one complains this kind of issue, then the producer side won't know there's something wrong on their end. Okay, the last challenge. Okay. So after we identify there's some issue in our data, how can we help our users to know what's the root cause of the data in a short time? This can be considered another challenges. Okay, so based on the above 3 major challenges, I would like to introduce the one solution, which is the real-time data quality monitoring with data contract, LLM, as well as the Flink SQL. So I'm going to introduce the solution in the 4 major components: data contract definition, configuration, transformation, test execution, as well as the observability system. This is a whole big picture of our architecture. So from the start, we have all the configuration defined here, and including the necessary configuration like a Kafka stream, schema configuration, and as well as the semantic test rules, which I'm going to talk more details about it later, and as well as the observability metadata. All of them, we consider it as a data contract definition. Well, after we have all this kind of definition, in the next stage, we are going to transform this kind of configuration into something that our test runner can understand, which is our configuration transformation stage. And in the third stage, Flink SQL will be our test runner to take out the configuration and read from the actual test Kafka topic to perform the real-time test. Once the Flink SQL identifies there is some data quality issue, it will sync all the test results with batch sample data into our data quality observability service. So there will be a real-time Slack notification to send to our data owner or producer owner to notify them there's something wrong with your data. You should take some actions. Apart from that, our observability service will also display what's the exact issue of the data. Okay, let's go into details, components by components. So first one, data contract definition. So here, yeah, we have it includes quite a few necessary configurations, including the Kafka stream configuration schema that the producer is using, and this schema also, the version of schema will also be used by the test runner, and as well as the observability metadata. This one includes some metadata like who shall I inform once I identify the data issue, and which channel shall I put the details about the data quality report. Okay, so this is the most important thing. We call that the semantic test rules. So the left-hand side is just a typical protobuf schema. So it defines booking entities with some necessary metadata. Well, on the right-hand side, we allow user to configure their semantic test rules using this nested schema with so that user, for example, user can just define the booking code should follow the pattern like start with a booking dash X, and cashless status should between 1 to 2. This is just an example. Okay, so there could be such scenario like for certain Kafka stream schemas, there might be hundreds or thousands of fields. If we ask a user to define the schema test rules for each field, this could be challenging for our users. And sometimes our user might not fully understand or fully remember what's the exact meaning of each field. So here, we use the LLM to provide such service to recommend the test rules based on our historical data. So by doing so, in this column, LM recommended, user can check the recommended test rules based on the suggestion and define their rules accordingly. So the rules have 4 major types, including the number range based on the historical data, as well as the type of the fields, string pattern, constant values, and a more complicated one will be the cross-field rules. For example, the upper bound should always larger equals than 0, while the lower bound should smaller and equals than the upper bound. Okay, after that, the config transformation engine will transform the user-defined rules into inverse SQL queries. So what does it mean, invert SQL queries? So instead of just writing queries to query those correct data, we choose to writing queries, automatically generate queries to query those bad data. Okay, since we have all the configuration, then we just put them together, including the Kafka Stream config, semantic test rules, which is a Flink SQL query, and as well as the observability configurations. We convert them into one configuration that can be understood by the Flink SQL, which is our test runner. Okay, during the test execution, for every Kafka topic, there will be one dedicated Flink SQL pipeline running as a test runner. And once the test is executed, the Flink SQL pipeline, which is a test runner, will consume from our target test topic and perform the test cross with Flink SQL query that user defined. Okay. After we identify there's some data quality issue, what will happen? Firstly, an alert will be directly sent to the stakeholders or the data owners to notify them there's something wrong with your data. Please take note and also take actions. But notification is not enough actually, because it might take user some time to understand what's really happened. What's the root cause of this kind of bad quality data? Then we attach the link of this kind of observability page to the notification. So on the left-hand side, it just provides the semantic test rules that use defined by the users. On the right-hand side, it's just the sample data of those data with a bad quality. And this one also highlights which field violates the rules that defines by the users. So using this way, we can help the user to reduce the debugging time from days, hours to a few minutes. Yeah, this is the complete solutions that we have for the real-time data quality monitoring. And that's also the end of our presentation. And we would like to answer any questions if you have.
If you have questions, you can ask more to QA.
Can you share some of the problems you wrote to let the LM to write what are the rules and what are the LM-based tests?
You mean this LM recommended? Okay, so I cannot fully remember the entire prompt, but basically we on the back end we have our own pipeline to fetch the historical data from our production, and we let the LM know based on this kind of. Okay, so basically there are two inputs. Firstly is a schema of this topic. We let LM know this is a schema that I want to use by this topic. Secondly, we provide a bunch of sample data. Currently, the data amount is like hundreds, for example, 100 number of events. So based on this schema and sample data, please help me to generate the rules of this for our users to define their semantic test rules. And these rules can be transformed into Flink SQL query directly. Yeah, this is how we manage it. Yeah.
Yeah, I had a question about the data contracts that you specify. Like, how complicated of the rules are you allowed to specify? Like, for example, things like, I don't know, if this field is enough of a particular value, then enforce contract on a different field or something like that. Like, I'm not sure what, do you have a framework that you plug into to define your contracts? You might have mentioned it.
A framework to define the contracts. Can I just confirm you are mainly asking about the semantic test rules or the entire one?
Just a semantic rule. So
Like
just curious what kind of-
interdependent fields tests.
Okay, so currently we are handling we are not actually handling 100% of the cases, like a very complicated cases, because for now our test runner is using the Flink SQL using the unbounded way. So for those bounded window one, which means stateful one, it cannot be handled. So currently we are only doing the event level test, which means to test the data event by event. So for those testing cross events, it cannot be handled for now. Okay. Any other questions?
The runtime for your Flink is Kubernetes, or what is Flink running on?
It's on Kubernetes.
On Kubernetes?
Yeah, it's on Kubernetes.
Okay.
Yeah, so basically we use the Flink application mode on Kubernetes.
Okay.
Yeah, so each of the pipeline will be a Flink cluster. Yeah.
Thanks.
So is there a way that you can dynamically update the rules and it will be reflected into the pipeline, or every time you change the rules, you actually need to restart the whole?
Actually, we built a fully automatic deployment system. As long as a user identify there's some issue or they would like to add a new semantic test rules, they want to update the rules, they only need to manage on this kind of UI UX. Then after one click, everything will be automatically set up.
So in the back end, it still stop and restart?
Yep.
Yeah.
I think that's it.
Okay, thank you so much.